This video is a follow-up to the first one regarding the probability distribution of a discrete random variable. In this video, we will take a look at how to find the mean, otherwise known as the expected value, and the standard deviation of a discrete random variable. If we think about the scenario from the last video, where we had the probability distribution of the number of boys a couple expecting triplets could have, we saw that they could have either 0, 1, 2, or 3 boys. And so from that distribution, we saw the probability of having no boys was 1 out of 8. Probability of having 1 boy was 3 out of 8. The probability of having 2 boys was also 3 out of 8. And the probability of having 3 boys was 1 out of 8. Now, if we create the probability histogram, what we're listing is x values on the horizontal axis and probabilities on the vertical axis. And then we want to be able to describe its shape. And so here's what we'll have. Okay, so what we have set up here are the axes for the probability histogram. This is the discrete probability distribution. So the histogram will look a little different maybe than what you're used to seeing. The x values are going to be centered in the middle of the bars, and along the y-axis I have scaled by 1/8, even though I'm only showing 1/4 and 1/2. And so for 0, my bar has a height of 1/8. For 1, my height is 3/8. For 2, my height is 3/8. And for 3, my height is 1/8. Think about, before we graph this, what you expect the shape to look like. And then as we graph, you can verify your predictions. So from the 0, I would go up to 1/8. And I would have a bar that's about that tall. And then for values of 1 and 2, I'm going to go up to 3/8. Actually, my bar was too tall. Let's try this again. So this is 1/8 for 0. That's better. And then for 1, I'm going to go up to 3/8. I'll be just as tall for 2 boys. And then for 3 boys, I'll be back down to 1/8. So this is what my probability histogram would look like. And we should recognize that shape as symmetric. So hopefully your prediction was right in describing its shape. So like with most distributions, we are interested in not only the shape, but the center and the spread as well. So the next goal is for us to find the expected number of boys. Expected value is just a fancy word for a weighted mean. In statistics, we represent it with the symbol mu, and we give it a subscript of the random variable, which we represent with a capital X. So this is equal to the sum of all of the x values times their respective probabilities. So I would take 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8, and that would give me an expected value of 1.5. And hopefully this makes sense to you. If a couple is expecting triplets, that's 3 children, the probability of any one child being a boy is 0.5, so I would expect half of the children to be boys, and so that's what that 1.5 is. This again has to do with the pattern that emerges in the long run. This is the long term or the long run weighted average. Now, how far can I expect this value to differ? Well, that's what the standard deviation will tell us. So let's take a look at that next. Okay, to find the standard deviation, as we did before, we begin with the variance. And so you will see the variance represented as sigma squared. Or sometimes you'll actually just see it written as a function variance of x, where x is the random variable. Similar to what I did before when I found the variance, I take each value, each little x, and I subtract the mean and square it. Ordinarily, I would then divide these by n minus 1. But knowing that I have the entire population and the frequencies attached to those, I would take this and multiply by p of x. So for the scenario that we have, that means that I would have the following. I would have the value 0 minus the mean 1.5 squared multiplied by 1/8 plus the value 1 minus 1.5 quantity squared times 3/8. 3/8. Try that again. I want that to be 3/8. Plus 2 minus the 1.5 quantity squared times 3/8. And then lastly, plus 3 minus 1.5 quantity squared times 1/8. And this again represents sigma squared, which is the variance. And what you will find is that we have a variance of 0.75, which means that my standard deviation, put a little subscript x here, my standard deviation is 0.866. And what this value tells us again is the average distance from the mean. So this is the same standard deviation interpretation that we would have used earlier in our exploring univariate data chapter. And so hopefully this gives you a little bit of information to work with. I will let you know that there is a way to do this on your TI calculators. I encourage you to find the technology toolbox in your textbook on how to do this. Let me know if you have any questions after watching this video. See you soon.